Montessori Grandma. Episode 52. Geography Part 1. Experiments on Story of Creation.
Montessori Geography Program for 6 to 12-year-olds, Part 1. Retold and presented by Geeta Vijaychandran. The first time we introduce geography in the elementary class is through the first grade lesson called The Story of Creation or God with No Hands. We have heard this story in an earlier video. This story leads to many topics in geography, astronomy, physics, chemistry, and more. However, in the primary and nursery class, children are introduced to static geography. What is static geography? In geography, static refers to things that don't change much or have a fixed position, while dynamic refers to things that change frequently or are constantly in motion. Examples of static geography are country borders, state borders, etc. Physical features like mountains, rivers, coastlines, etc. Maps that display fixed geographical information are all static. When we are looking at maps in a book or chart, it is static. There is no movement involved. Maps can be static and dynamic. Dynamic refers to things that change frequently or are constantly in motion. When we are using puzzle maps and moving the pieces, it is dynamic. All Montessori materials are made in such a way the children can manipulate them, and this helps in understanding the concept by intellectually using their senses. In the nursery or primary classes, children are introduced to two globes. The first is for land and water, and the second is for continents. In addition, there is a world map puzzle maps of the continents and the land and water forms. In the elementary classes, children do the same, but in more detail. They draw, make books, and learn the names of the continents and oceans. Children make land and water forms using clay. In the elementary, we look at the structure of the earth using flannel pieces to show upfolds and downfolds, card materials to show folds and falls. We also have a large set of classified nomenclature for the landforms. Montessori uses charts for all subject areas. Montessori charts are designed to spark imagination and facilitate a deep understanding of the world. They emphasize hands-on learning and sensory exploration, and they do not stick to traditional rote memorization. The aim of the charts. The charts, often referred to as impressionistic charts, aim to create vivid mental images that foster a lasting appreciation for different cultures, physical landforms, and the interconnectedness of the world. The key principles of the Montessori geography charts. The first is sensory engagement. Children interact with materials like puzzles, globes, and land and water form models to grasp geographical concepts through touch and manipulation. Next comes hands-on learning. Montessori emphasizes active engagement, allowing children to build, explore, and discover through activities. Other principles: imagination and impression. Impressionistic charts with their vivid imagery aim to capture the child's imagination, leaving a lasting impression rather than relying on dull and lifeless facts. Big pictures to details. Montessori geographical approach starts with a broad overview of the world and gradually narrows down to specific details, fostering a comprehensive understanding of concepts. More principles: interconnectedness of the world. Montessori geography highlights the relationship between different cultures, environments, and the needs of people across the globe. The cultural appreciation. Children are introduced to various cultures, traditions, customs, and the ways they interact with their environment. Direct experiences. The use of puzzles, maps, and models allow children to build a strong foundation of geographical knowledge through direct experiences. Here are a few charts we looked at in the story of creation. One, cooling of the earth. The second one, the time of volcanoes. The third one, arrangement of the planets around the sun. And the fourth one was the size of the earth compared to the size of the sun. Experiments to go with the story of creation. The first experiment is how cold ice is. Second one was balloon popping and materials clinging together in water. The third one, 3 states of matter. Fourth was arrangement of particles according to their weight. Fifth experiment was properties of particles. Sixth was particles that love each other. Seventh, particles that don't love each other. Eighth one, particles that seem to love each other. And the ninth one was volcano eruption. Refer back to the story of creation, when each of the special particles were given different laws. In this way, they formed different groups. Let us do some experiments to see whether particles love each other or not. The first experiment, material description. We need one tray, 2 identical glasses with salt in one and water in the other, and a glass rod. The process, pour the salt into the water and ask the child to stir. Let's see if these particles like each other. We can see the salt is mixed completely in water. Now note that we do not do evaporation at this time. Experiment 2. Material description. A tray, 2 identical glasses with water in one, half a teaspoon of finely crushed copper sulfate crystals in the other, and a glass rod. Process, pour the water into the copper sulfate and invite the child to stir. Do these particles like each other? Let us keep it and see what happens. Write your observations. Experiment 3. Material description. Water, an acid-resistant dish that can be made with porcelain with hydrochloric acid, that is, we want 1 part water to 4 parts acid. A chip of marble and gloves. Procedure. This is a dangerous experiment, so keep the hydrochloric acid in a closed container. Keep the children away from the acid and the fumes. Very carefully pour the acid into the marble chip. Do these particles like each enough to merge? It may take up to 10 minutes. A chemical reaction occurs, producing carbon dioxide gas and calcium chloride and water. The carbon dioxide gas released causes the marble chip to whiz and bubble. Remove the experiment when complete, pouring the acid down the drain with lots of running water. Experiment 4A and B. Material description. A tray, a rack for test tubes with 4 test tubes on it. 4A, the first test tube contains water and the second has an inch of sand. In experiment 4B, the third test tube has water and the fourth test tube contains half a teaspoon of chalk powder. First, pour the sand into the water, place on the holder and invite the child to shake it. Do these particles like each other? Eventually, we can see that they will separate. 4B, procedure. Pour the chalk into the water, place on the stand and invite the child to shake it. Do these particles like each other? Look for the results. Eventually, we'll see that they will separate. Note, we can refer to the calcium carbonate being deposited on the bottom of the sea in the story of creation. Experiment 5. Material description. 2 identical saucers, one with a teaspoon of sand and the other with a quarter teaspoon of fine iron filings, and a magnet hidden in a white handkerchief and a plastic spoon for mixing. Procedure. Transfer the iron filings into the sand and invite the child to mix them with a spoon. Say, at first they seem to like each other, but at the end they go their separate ways. Produce a handkerchief with a magnet. We hide the magnet at first and separate the sand and iron filings. Experiment 6. Material description. Two identical saucers, one with a teaspoon of sulfur powder and the other with a quarter teaspoon of fine iron filings. A magnet hidden in a white handkerchief and a plastic spoon for mixing. Process: transfer the iron filings into the sulfur and invite the child to mix them with a spoon. These are like people on a train. They sit side by side, but when they get to their stop, they go their separate ways. Produce a handkerchief with a magnet and separate them. After the experiments, give the term solution for the first three experiments, matter in suspension and deposit for experiments 4A and 4B, mixture for experiments 5 and 6. Notes: we are showing physical changes which are either reversible or irreversible. Aim: to show how some substances change when they combine, dissolve and mix, while others neither dissolve nor mix. Experiment 7A. Material description: 2 test tubes on a stand, 1 test tube with a concentrated solution of 2 teaspoons of copper sulfate in 50 milliliters of water with temperature of 60 degrees. 1 test tube with an inch of ammonia. Method: pour the ammonia into the copper sulfate solution. Something drops to the bottom and it makes something new. Do not shake. Here notes to demonstrate precipitation. Experiment 7B. Material description: 2 test tubes on a stand, 1 test tube with a pinch of potassium dichromate and 1 test tube with lead nitrate in liquid form. Or mix 1.5 teaspoon of lead nitrate crystals in a small amount of water. Method: slowly pour the liquid nitrate into the potassium dichromate solution. Watch what happens. It is turning cloudy. We are making something new. Do not shake. Give the term precipitate. It means tiny particles of solid suspended in a liquid. It shows a chemical reaction has happened. This is when chemicals react together to produce one or more new substances. A chemical reaction cannot be reversed. Notes to demonstrate precipitation. Experiment 8. Material description: a cup and a saucer, a few drops of ammonia on cotton wool, prepared in advance and wrapped up in cling film, a little drop of iron chloride or hydrochloric acid, and gloves. Method: ask the children to check if anything is on the cup and saucer. No. Wearing gloves, put the cotton wool on the base of the saucer and the drop of acid in the cup. Place the saucer on top of the cup for a minute or two and then lift it off. Oh, we have made some smoke. Notes: tiny crystals of sulfur have been produced which are floating in the air. This is a sign that a chemical reaction has taken place. Experiment 9. Material description: heat resistant tray with a Pyrex container, 100 grams sugar, 50 milliliters of sulfuric acid in a closed bottle, glass rod for stirring, gloves and tongs for holding the container. Method: do this experiment outside. Fill the container 1/3 full of sugar, pour the acid onto the sugar and mix them together with a glass rod. Describe the changes you see in terms of color, smoke, solidification, formation of black substance. Oh, we have made some carbon or coal. Leave it to cool. Notes: safety: avoid the fumes. Do not touch the carbon. It is very hot. After an hour or so, it will have cooled sufficiently for the children to touch. Notes on all experiments. Keep the experiments available for the next few days for the children's further observation and questions. Anticipate the question: can we reverse the reactions? Why mixtures, suspensions, and heated solutions would separate, the others are not reversible? Is there a limit to what solutions can hold? Try to see how much of substance can be dissolved. Example: how much salt or sugar can be dissolved in a small amount of water with heat. Make a special supersaturated solution because heat helps boost water's power to dissolve. At a later stage, give more information about the experiments. The choice of experiments will be determined by the children's level of normalization and the numbers of experiments in one sitting. Keep the experiments in clusters. Example, solutions, suspensions, mixtures, precipitation and crystallization, and then chemical reactions. This brings us to the end of geography, first part, experiments on story of creation. Thank you for watching. This is Geeta Vijayachandran signing off.
Montessori Grandma.